Hello, PreCalc. It's still April the 1st, and you are to view this video sometime this weekend. So, we're going to be studying properties of logarithms. The properties of logarithms I'm going to introduce in this way, and then I'll gather them all in one spot and show them to you. So the first one, I was wondering, were you as well, if the log of to the base unknown b, some base of a value u times v, could it possibly equal the log to the base b of u times the log to the base b of v? All right, so I was wondering if you're taking the log of two factors that are multiplied, do you think it could possibly equal this? So we're going to test it, and we'll take one that we know. Log to the base 10 of, say, 10 times 100. Does that equal log to the base 10? Right, according to this formula, we're going to split this up, these factors up. Log to the base 10 of first the 10, and then log to the base 10 of 100. So following this rule, this one can be broken down like that. So let's see if that's true or not. And we know 10 times 100 is 1,000. So what is log to the base 10 of 1,000? What exponent do I give 10 to get 1,000? And the answer is 3. And then over here, what's the log to the base 10 of 10? What exponent do I give 10 to get 10? 1 times log to the base 10 of 100 is 2. So, does 3 equal 1 times 2? It does not. But 3 equals 1 plus 2. So it turns out, if I go back to my original statement, which I had a question mark above, this is true. Now, that's not a rigorous proof, but I have shown you, at least by example, that it works in one case, and it works in all cases. So that's the first property of logarithms. Second one is I'm going to look at the same idea, but I'm going to divide. So say I take log to the base b of u divided by v. Could that possibly equal log to the base b of u divided by log to the base b of v? No. We'll see if it does. All right, we'll go by example. Log to the base 10 of, say, 100 divided by 10. Does that equal log to the base 10 of 100 divided by log to the base 10 of 10? So can I split these two up and make them individual logarithms? So let's see. Well, 100 divided by 10 is 100. Log of to the base 10 of 100 is 1. And I lost you. There we go. And this one is 2, and this one is 1. So is 1 equal 2 divided by 1? It does not. But 1 does equal 2 minus 1. So, looking at that, let's go back to our original question here. And we're going to switcheroo it. Instead of dividing the two logs, we're going to subtract them. And perhaps this isn't too much of a shock, because look at how logs are exponents, right? So is an exponent of, say, 2 x to the 2, there's an exponent, times x to the 3. We don't multiply them, we add the exponents. So that is x to the 5th, not x to the 6th, so x to the 5th. So it follows that logarithms, when you have two logarithms that are multiplied together, you can split them into two logs by adding And here we have a log of two quantities divided. We can write them into individual logs subtracted. There's one more log rule, and I will give it to you straight off and see if an example will bear it, at least in one case. Log to the base b of u to the n equals, that exponent can become a coefficient in front. And that will always work. And let me show you a case so it won't look too unusual. Let's see, I will do log to the base 10 of 100 squared. So I'm going to do log to the base 10 of 100 squared. Does that equal the same as this exponent can run down in front and be a coefficient, log to the base 10 of 100. So let's see if that's true. Well, 100 squared is what, 10,000? What's log to the base 10 of 10,000? What exponent do I give 10 to get 10,000? 4? Keep losing you. Why do you keep leaving? All right. So let me pull back a little. Oops, wrong way. All right. So 4, does it equal 2 times log to the base 10 of 100, which is 2? It does. So this is a rule of logarithms. So I pulled them all together in one nice little spot. So if you have a formula sheet floating around in your comp book, these should be added to it. And we will be using them when we come in on Monday. Here's one way we'll use it. I can use this rule. I'll leave those there where we can see them. And I'm going to go over here and do a problem, going back and forth to grab a log rule when I need it. So let's say, or maybe I can put them in top. There we go. All right, so I want log to the base 5 of the cube root, log to the base 5 of cube root of 5. All right. So I'm going to use log rules to simplify that. I can do that first we know how to rewrite a cube root with an exponent, so we'll do that. It's 5 to the 1/3. And the rule of exponent says that anytime we have a log with a argument raised to an exponent, it can run down in front and be a coefficient. So we're going to let the 1/3 become a coefficient. And then we know this part, what exponent do I give 5 to get 5? So I get 1/3 times 1, and it equals 1/3. So all of that equals 1/3. So see how log rules. And that's part of the reason we actually use logarithmic expressions, because these rules of logs are so powerful. Let's try this one. We'll do ln of e to the 6th minus ln of e squared. So on that one, we will do a similar thing. We'll let the exponent run down in front. This part is called the argument, that to which the log is applied. And so when you have an argument raised, when you have an exponent in the argument, it can run down in front and be a coefficient. So both of the exponents became coefficients. And now we know this part, ln is base e. So what exponent do I give e to get e? 1. And same thing over here, 2 times 1. And I'm going to get 6 minus 1 equals 4. All right, so all that became a 4 using rules of logarithms. They're very powerful in the calculus. They make a lot of steps that are undoable, otherwise quite doable. We will also use these laws to expand and condense expressions. And let me show you how that works. Let's say if I do, sorry, I'm taking all around the town here. Log to the base 4 of 5x cubed y. So I want to use laws of logarithms, which I'm keeping in view there, to expand it. When I expand it, I don't want any logarithm, I don't want anything in my expression that has a exponent greater than 1. So here's the whole argument, here's the base. And we learned up here that when things are multiplied together, they can be separated by individual logs added. So expanding sounds like it's going to grow, so I'm going to grow it. So you see how I have all these things that were multiplied together. I'm going to add them as individual logs. Where I had 1 log, I'm going to expand it into 4 logs, like that. And can I apply the logs rules on any of these other expressions? Yes, I can, because here is an exponent in an argument. It can run down in front and be a coefficient. So this is called the expanded form. And it's important in step in calculus when you're trying to take the derivative or integral to get it out of this form and into this form. And let's see what else. One more. We'll go the other way. So that was an expand. Let me show you a condense. So we're going to condense this one. So we're going to take log rules, so I'll leave them up there. I'll be back in a second. I'm grabbing the problem from under the sheet. That'll be a better way, but this will do. All right, this time I'm going the other way. This is already expanded, and I am going to go the opposite way and condense it. So I want it to become 1 term. Now there's 2 terms. I want it to condense to 1. First of all, I'm going to take the coefficient and make it back into an exponent. So now there's an exponent in the argument. And this one can dance around back here. And to further condense that, I can look at this rule of logarithms. Come back in the screen. This rule of logarithms says when there's 2 logs that are added, I can go this way and write them as 1 log multiplied. So I'm going to take these arguments and put them together by multiplication. X to the 1/2 times x plus 1 cubed. So I have condensed from this expanded form to this condensed form. And we'll practice some of that as well. All right, that's all I have for you. So I hope your weekend is going well, will be going well, or has gone well, depending when you view this. So I'll see you Monday. Bye.